Yes, so I'm Sergiu Carpov. I'm working as a senior cryptographer at Arcium, and my main interests are for fully homomorphic encryption and PC, and more particular implementations and optimization, like compilers and optimization algorithms. It was, I think, 2011 when I first read the fully homomorphic encryption BGP paper. And yeah, at the same time, I was at the CA, French Research Institute, and we started working on the compiler chain for fully homomorphic encryption, and it resulted in the Chinguata compiler. And from that time on, I switched to cryptography and more to applied cryptography, optimization techniques for cryptography, and compilers for, for cryptographic techniques for computing on encrypted data. Um, I don't think I have a favorite one. Yeah, each time I'm working on a new paper or on a new scheme, I like this kind of scheme because I'm into it at this moment of time. TFHE is easy to understand because you have all this hardware synthesis background or research community which is the implementation of the application is using a TFHE. But at the same time, it's suboptimal for some use cases, and in this case, you can switch or you can use yeah, BFV or CKKS becomes my favorite ones. So it actually depends on the application you are implementing. Uh, I think it was a pure hazard. I started working in FHE. During my PhD years, I worked on a compilers for data flow programs, more like hardware oriented. And afterwards, I started working on FHE because it was also compilers for FHE. So it's like it was a smooth transition of compiler backend from hardware high optimized algorithms applications to FHE applications, to encrypted data applications. Biggest challenge was to implement the BFV paper. So because I was new into cryptography and understanding all the remembering the algebra which I studied in high school was challenging. And one of the first my first multiplication where you multiply the two by two polynomials and you do the relinearization step, and it worked. I was satisfied with myself at this time. But yeah, implementing the first BFE scheme was challenging. I I cannot do predictions. That for me it will be used in use cases where the price of privacy is more important than the cost of the computation on encrypted data. Because finally, if you if you are willing to pay for FHE, for computation done in FHE, there must be incentives from the privacy part, because otherwise you will never do in a real use case. You never use FHE in a real use case if there's no incentive from the privacy. Usability. So usability of FHE by developing new tools which are more automatic, which require less intrinsic knowledge about the FHE schemes. And also another aspect will be the education of developers to be aware of FHE and what can be done in it. Try to implement things with FHE. This way you will understand the limitations and you'll better understand schemes, and you'll change your way of thinking from, for example, if you have computer science background, you must switch the way of thinking when you program for FHE, when you program for a CPU, because even if tools and compilers will improve for FHE, it will always be like implementing an application in C++ or in assembly. You'll always obtain the best performance when implementing assembly and application, and this will this will apply also to FHE, because you'll always be able to obtain the best performance if you implement an application in a low-level FHE library, like not using and not letting the compiler do the work for you, but implementing low-level FHE instructions.